Hello, students, and welcome. Today, we are going to understand a very important and often confusing topic from our physics syllabus, the difference between mass and weight. You see, in our daily lives, we often use these two words as if they mean the same thing, but in physics, they are completely different. So let's clear up that confusion once and for all.
So here's the roadmap for our lesson today. We will start by understanding what mass is. Then we will move on to what weight is. After that, we'll take a little trip to the moon to see how weight can change. We'll compare mass and weight side by side, and finally, we will summarize everything with some key reminders. We will build our concepts step by step to make sure everything is perfectly clear.
But before we begin, let's think about a simple, everyday experience. Imagine you have a very heavy box, maybe a big steel almirah, and a small light stool. Why is it so much more difficult to push the heavy almirah, even if it's on wheels, compared to the small stool? That feeling of resistance, that's a key idea we're going to explore.
Okay, so let's dive into our first concept. This feeling of resistance brings us to the idea of mass. What exactly is it?
Now, as per our textbook, this is the scientific definition. Mass is the measure of an object's inertia. But what does inertia mean? Well, you can think of inertia as an object's laziness, or its resistance to any change in its state of motion. If an object is resting, it wants to keep resting. If it's moving, it wants to keep moving. So more mass means more inertia. That heavy almirah had more mass, so it had more inertia, and that's why it resisted being moved so much.
Now, this is the most crucial point about mass, and I want you all to remember this very carefully. The mass of an object is constant. It never changes. It does not matter if you are on the Earth, on the moon, or even in deep space where there is no gravity. The amount of matter, the stuff you are made of, remains exactly the same. So your mass is constant everywhere.
All right. So if your mass is constant everywhere, then what are you measuring when you stand on a weighing scale? Well, that brings us to our next concept. Now we will discuss what weight is.
So you see, weight is not something that an object possesses by itself. Weight is a force. Specifically, it is the force of gravity that is pulling the object's mass towards the center of a planet like our Earth. This means weight depends on gravity. If there is no gravity, there is no weight.
And this brings us to a very important formula. Weight, which we represent with a capital W, is equal to mass, m, multiplied by the acceleration due to gravity, which we call g. So W equals m times g. This formula actually comes from Newton's second law of motion, F equals ma. Here, the force F is the weight W, and the acceleration a is the specific acceleration caused by gravity, g.
Now, since weight is a force, its SI unit is the same as the unit for force, which is the Newton, written with a capital N. A very common mistake that students make is to write weight in kilograms. Please remember, kilograms is the unit of mass. The correct unit for weight is the Newton. This is a very important distinction.
Now that we know that weight depends on gravity, on the value of g, what do you think happens when we go to a place with different gravity? For example, what if we go to the moon? Let's see.
This is where it gets really interesting. The amount of matter in you, your mass, does not change. So your mass on the moon is exactly the same as your mass on Earth. But the moon is much smaller than the Earth and has less mass, so its gravitational pull is much, much weaker.
How much weaker is it? Well, the moon's gravitational force is about 1/6 that of the Earth's. This fraction, 1/6, is the key. So here is the crucial point. If an object weighs, say, 60 newtons on Earth, on the moon, it would weigh only 1/6 of that. So 60 divided by 6, that is just 10 newtons. The object would feel so much lighter even though its mass has not changed at all. This is why you see astronauts taking those big floating jumps on the moon's surface. Okay, now let us put all our learning together. We are going to clearly list out the differences between mass and weight to avoid any confusion. This will be very helpful for you. This table clearly summarizes the key differences. So first, let's look at the definition. Mass is the measure of inertia, while weight is the force of gravity. Second, the SI unit. Mass is in kilograms, kg, while weight is in newtons, n. Third, constancy. Mass is constant everywhere, but weight varies with location because the value of g changes. And finally, nature. Mass is a scalar quantity. It only has a value. But weight is a vector quantity. It has a value and a direction, which is always downwards, towards the center of the planet.
To conclude our lesson, let's quickly revise the most important points that you need to remember, especially for your exams.
So, these are the core concepts. First, mass is the measure of inertia. It is constant, and its unit is the kilogram. Second, weight is the force of gravity. Its formula is W equals m times g. It varies with location, and its unit is the Newton. Third, an object will always have mass, even in deep space, but it can be weightless if there's no gravity acting on it. And fourth, an object's weight on the moon is 1/6 of its weight on Earth. Please memorize these definitions, the formula, and this key difference about their constancy.
And with that, I will leave you with a final thought to test your understanding. So think about this. If a person has a mass of 60 kilograms on Earth, what is their mass on the moon? Think carefully about what we learned today. The answer is in the most important property of mass. Thank you, and keep learning.